Hello friends, yesterday we discussed about the SN2 reaction, that is nucleophilic substitution biomolecular reactions. Okay, in that we see that there is kinetics of the SN2 reactions or transition state, energy profile diagram, stereochemistry. So let's see the details of stereochemistry of SN2 reaction. So in this in SN2 reaction we always observe the inversion. So what is inversion? Inversion means if we take chiral center in the reactant, then if we consider there is a R configuration, and after the reaction completion we get the obtained product contains S configuration, then there is a change in configuration, that is called inversion. So inversion in the reaction. Okay, so let's see how there is a inversion in the SN2 reaction. For that purpose, we have to consider how nucleophile approaches towards the carbon. Okay, so there are three ways. There are three ways to reach nucleophile to the carbon. So when we know that the more favorable is the backside attack. So let's see how backside attack is more favorable in case of SN2 reaction. Let's consider first backside attack. Backside attack. So let's say how inversion is possible or it take place in SN2 reaction. So for that purpose we have to consider how the nucleophile approaches towards the carbon. Okay, so for that purpose there are three ways by which nucleophile approaches to the carbon. There are three possibilities. So first possibility is the backside attack, and we know that we already discussed about backside attack is more favorable. So in this point we have to consider only the stereochemistry. For that purpose we repeat this backside attack. Okay, so we know that nucleophile having negative charge, and because of the polarized bond, this carbon getting a positive charge and attraction towards the nucleophile. Okay, so whenever this backside attack is more favorable because there is a no steric repulsion between the nucleophile and leaving group. So here is bromine is a leaving group. So this is a leaving group having a negative, partially negative charge, and we know that the nucleophile also having a partially negative charge. If nucleophile approaches from the backside, at backside there is a no steric repulsion or no steric hindrance to the nucleophile to attack the carbon. Okay, so that's why this attack is more favorable. After the attack there is a formation of transition state which is very stable, because there is a 5 members transition state which having a sp2, actually which having a sp2 hybridization, because these both bonds are the partially formed or partially break. So these two bonds are perpendicular to these three hydrogens which are in a single which are in a one plane. So this transition state having a sp2 hybridization and having a minimum steric repulsion, okay, steric hindrance. So this transition state is well stabilized. That's why backside attack is more favorable. After the formation of OH bond and departure of carbon bromine bond, there is formation of the products. Okay, so in this if we consider the hybridization changes, so we know that this is aliphatic carbon which having a sp3 hybridization which changes during the reaction, because after the formation of transition state there is a change in hybridization which is sp2, and after the breaking of transition state there is formation of the product which having a hybridization is sp3. Okay, so there is hybridization from change in hybridization from sp3 to sp2 and sp2 to again sp3. So there is a change in hybridization also. Next possibility is front side attack. Next possibility is front side attack. Okay, there is a second possibility, front side attack. Okay, so nucleophile approaches to carbon atom from the front side, that is from the leaving group side. So we know that the leaving group also having a negative charge, and this carbon having a positive charge, nucleophile having also negative charge. So whenever the nucleophile tries to approach this carbon, there is a steric repulsion between the nucleophile and leaving group, because both having a negatively charged. So there is a dipole-dipole interactions or repulsion between the nucleophile as well as leaving group. So there is a steric repulsion. So there backside attack is not favorable in this case. And if we see the transition state of this mechanism, this possibility, then we see that the this transition state having a steric crowding, because these three hydrogens are in and these five. If we see the transition state of this mechanism or this possibility, we see that there is a 5-member transition state which is very crowding, and there is a steric repulsion between the nucleophile as well as leaving group. So this transition state very unstable. Also there is a no hybridization changes, because this having sp3, here is no change in hybridization. So activation energy for this transition state is very high, which is very high. So this possibility is very less in case of SN2 reaction. So after departure of leaving group, there is formation of this product. So this possibility is very less in case of SN2 reaction, because of steric repulsion between the nucleophile and leaving group. Okay. So third point is other possibilities of attack. So nucleophile attack from front side as well as back side. There are so many possibilities, because this nucleus, this carbon get attack from this side also, this side also, this side also, or this side, or this side, or this side. All these possibilities results into the front side attack. Okay. Or nucleophile can approaches from this side, this one, or this side. So all these possibilities results in the backside attack. So all these possibilities from this side results into the front side attack, ultimately in the transition state, and this also comes in the backside attack. So thermodynamic study also proves that there is a backside attack is more favorable in case of SN2 reactions. Okay. Experimental proof for the inversion of configuration. Experimental proof for inversion of configuration. Okay. For this purpose, we have to consider a chiral center in the molecule. Okay, because without chiral center, we cannot distinguish the change in configuration. If we take simple methyl bromide, we cannot distinguish change in configuration, because this is not a chiral center, because after the formation of product we cannot distinguish the change in configuration. So for this purpose, to show the inversion configuration, we have to consider this carbon is a chiral carbon. So let's take example. Okay, let's say experimental proof for the inversion of configuration. For that purpose, we have to consider the chiral center carbon in the molecule. Okay, so let's take an example of 2 bromo butane, which having a R configuration. Okay, if we react this 2 bromo octane with the NaOH, there is a nucleophile SN2 reaction, that is attack of OH from the back side is taking place. So in this after the attack of nucleophile, there is a departure of bromine. So this is considered a mechanism, that is this OH bond forming and CBr bond breaking take place simultaneously. So there is transition state which having a 5-member character. So this transition state also having sp2 hybridization. So after departure of leaving group, there is a fully formation of OH bond. There is formation of 2 octanol. Okay, which having change in configuration, that is S configuration. So this is also a chiral center, okay, which having a configuration S configuration. If we compare the specific rotation, here is a minus 39.6 specific rotation. After the formation of product, if we take the specific rotation, it becomes a plus 10.3. So here is a plus sign. This indicates that this is a change in specific rotation. Okay. So here is minus sign. So this is minus sign. So this shows that there is a change in configuration, because reactant having a R configuration, a product having a S configuration. This shows that there is a in SN2 reaction there is a change in configuration. Okay. So this also proves that there is a backside attack in case of SN2 reaction. Let's take another example for the inversion of configuration. If we react the optically active R1-phenyl 2-propanol with toluene sulfonyl chloride, that is TSCl. So there is a formation of tosylate. How this is formed? This lone pair attacks on this toluene sulfonyl chloride. There is a leaving group chloride is eliminated. So there is formation of tosylate. This tosylate is converted into acetate by reacting this tosylate with the sodium acetate. So this sodium acetate attacks from the backside of this tosylate ion. Okay, so there is a minus OTS is leave from this reaction. So there is formation of acetate. After in the third stage, this acetate ion is converted into the enantiomers of the starting material alcohol by simple hydrolysis. So at the end we get yes 1-propyl 1-phenyl 2-propanol. So if we compare the starting material and end product, we observe that there is a change in configuration. So in the starting material there is a R configuration, and at the end there is a change in configuration, that is S configuration. So this is an enantiomers to each other because change in configuration. This shows that there is a inversion of configuration in SN2 reaction. So this is a SN2 reaction, okay, because it attacks from the backside. So this is the evidence for the inversion of configuration. Okay, let's take another example which proves that there is an inversion of configuration in SN2 reaction. If we react R2 iodo-octane with iodine I28, that is isotopes of this iodine. Okay, so there is a attack of iodide 128 from backside in case of SN2 reaction. If we compare, so there is a formation of transition state. We know that this is a transition state, 5-member transition state, which is very stable because there is changing in configuration. So there is change in hybridization. So after departure of leaving group, there is a formation of this product, that is S2 to iodo-octane. So if we compare the configuration of reactant and product, there is change in configuration because reactant having configuration R configuration and product having a configuration is S. So there is we observe that there is change in configuration, that is and there is change in configuration means inversion of configuration. So this experimental prove that there is a inversion in configuration in case of SN2 reaction by attacking. This is possible only when there is a backside attack of nucleophile. Okay, backside attack of nucleophiles. Thank you.